Before we begin, just a brief note for those who follow this work closely. Subscribers to the Echoes of Valor email list receive carefully researched ebooks, detailed videos showing real woodworking projects built step by step, and timber-related material that honestly is not published publicly. The intent here is careful documentation and long-term understanding, not promotion. What follows stands on its own, but the deeper archive lives there. Now, let's get to the subject. The moment a tree was cut mattered as much as how it was shaped afterward. Old-world carpenters did not see tree felling as a neutral first step. They saw it as the beginning of the timber's entire future. Strength, durability, resistance to decay, and long-term stability were all influenced by when the tree was cut. This was not folklore or superstition. It was a practical conclusion reached after generations of watching buildings succeed or fail. To ignore cutting season was to gamble with the material. To respect it was to stack the odds in favor of longevity. Wood behaves differently depending on what the tree was doing when it was felled. Trees are not static structures. They are systems in constant motion, moving water, sugars, and nutrients through their fibers. Old carpenters understood this, even if they lacked modern biological terms. They knew that a tree cut during active growth behaved differently from one cut during dormancy. In spring and summer, sap rises. Cells are full of moisture and sugars. When wood is cut in this state, it dries unevenly, shrinks more aggressively, and becomes more vulnerable to insects and decay. Winter-cut timber, by contrast, contains less free moisture and fewer sugars. It dries more slowly and evenly, and it resists biological attack longer. This difference did not always show immediately. It revealed itself years later, when one beam remained sound, while another softened or twisted beyond use. Winter cutting was a rule born from observation, not ritual. Across Europe and much of the Old World, winter felling became standard for structural timber. This was not because winter was convenient. It was often harder and more dangerous. Trees were felled in snow, hauled across frozen ground, and worked in cold conditions. Builders accepted this hardship because the results were clear. Winter-cut wood was stronger for its size, more predictable in seasoning, and longer-lasting once placed in a structure. Floors creaked less, roofs sagged more evenly, joints stayed tighter. The rule persisted because it worked. One of the most important differences between seasonal cuts was sap content. Sugars present in sap attract insects and fuel fungal growth. Old carpenters may not have known the chemistry, but they knew the outcome. Timber cut in high sap seasons was more likely to suffer early decay, especially in damp or enclosed environments. Even when dried, residual sugars remained locked within the wood. Winter-cut timber, lower in sap, offered fewer nutrients to pests. This alone extended the life of buildings in ways modern treatments attempt to replicate artificially. Drying behavior changed with the season of felling. Wood dries by losing bound and free water. When cut during active growth, moisture content is high and unevenly distributed. As the wood dries, stresses develop that can cause internal checking, surface cracks, and distortion. Old carpenters noticed that summer-cut timber twisted more and split unpredictably. Winter-cut timber seasoned more calmly. It still moved, but the movement was slower and easier to accommodate. This mattered greatly in joinery. Stable wood preserved joint integrity. Unstable wood tore joints apart from within. Cutting season influenced how wood carried load decades later. Strength in timber is not just about initial stiffness, it's about how the wood behaves under constant load over time. Old builders observed that summer-cut beams crept sooner, sagging under weight earlier in a building's life. Winter-cut beams compressed more slowly and evenly. Their fibers, less disrupted by rapid drying, retained greater resistance to long-term deformation. This difference was subtle but decisive. Buildings framed with winter timber aged gracefully. Those built with poorly timed cuts required correction or reinforcement much sooner. Old carpenters matched cutting season to intended use. Not all timber was treated the same. While winter cutting was preferred for structural members, other uses allowed more flexibility. Firewood, fencing, and temporary structures were often cut when convenient, but for beams, posts, rafters, and long-lived joinery, season mattered. The most important wood in a structure came from the most carefully timed cuts. This selective discipline reveals how seriously old builders regarded the material. Modern tools did not change the tree's biology. Chainsaws, mills and kilns altered how quickly wood could be processed, but they did not change how trees grow or how wood behaves. The same biological rhythms still govern moisture, sugars, and fiber structure. Old carpenters worked within those rhythms. Ignoring them does not make them disappear. Understanding cutting season is not nostalgia. It is biological literacy. Wood rewards those who respect its seasons. The lesson carried through centuries of timber construction is consistent. When trees are cut at the right time, wood behaves better for the rest of its life. When timing is ignored, problems are merely delayed. Understanding this does not require abandoning modern methods. It requires remembering why old ones existed. If this kind of long-form, material-focused knowledge matters to you, consider joining the Echoes of Valor email list. That is where the deeper research, extended documentation, and detailed timber studies are shared, carefully, quietly, and with the time they deserve.